Welcome back to the Building a Business series, where I take you through the process of building a software business. Today I'm going to do a quick update on what we did since the last video, and I'm also going to do a little bit of a whiteboard session about the architecture of the data ingestion process that we're using to get data from the Securities and Exchange Commission into our database. And if you were here for the last video, link will be up there somewhere. You'll know that we're using something called Supabase, which is a backend as a service alternative to Firebase that uses a bunch of open source software in order to provide similar functionality to Firebase. So, since the last video, I've mostly been working on this data ingestion process. I've been working on this data ingestion process for probably, a month now, something like that. Maybe not a month, maybe 3 weeks, interspersed with some other things. But essentially, at the end of the last video, I had finished doing the transformations of the data. So when we get the data from the Securities and Exchange Commission, it's in this raw format, we have to transform it into the format that we want so that we can insert it into the database. So that was done. All the stuff that I've done since that last video is in relation to actually inserting that data into the database and then doing optimizations so that the insertions actually happen at a reasonable pace. So I'm going to quickly take you through the architecture on the whiteboard. So let's do that. All right, hopefully you can hear me okay on my phone. I'm just going to hold it up and see how this goes. This is an ongoing testing process. So, okay, the first thing, there's 3 stages. The first stage is a download stage. So I'll just write it out across the top and then I'll go through it. So download. And then we've got a transformation stage. And finally, we have, I hope you can see that. Okay. I might have to write a little bigger next time. Finally, we have an upload stage. And the upload stage goes to the database. Downloads stuff from the Securities and Exchange Commission, and transform just gets it into the format that we need in order for the upload stage to actually use it. So I'm just going to point out a couple things that are important for this to work, one, properly, but also efficiently. So the way I've got this set up is that each of these stages are a separate process on the computer. So if you watch my multiprocessing video, you'll know that if you're running multiple processes, those can be assigned to multiple cores on your CPU, which means 1, they can run at the same time, and 2, since they're separate cores, they're going to run faster, because if you try and load all of your program onto one core, it's going to have to, each process is going to have to wait for something else to finish before it can start doing work. So they're all multiprocessing. And so the download stage gets its information from the SEC. And these are all running at the same time. I'm trying to think if there's anything that I'd want to point out about the download stage. I don't have it implemented yet. It's going to be the next thing I implement, but essentially it's going to be listening to something called an RSS feed. Oops. And an RSS feed, I can't remember what the acronym stands for, but essentially it's like a web endpoint that continuously updates with information live. So I'm going to be listening for this. There's also a bulk stage, because the RSS thing is only useful for live updates, whereas I need to get, when I run the script the first time, I need to get all of the records. So transform phase, again, this is just going to take the data that's downloaded, and it's going to put it in the format that we need it to be in so that the upload stage can use it. And each of these stages has a queue. So that's how we implement communication across each of the phases. So when something finishes in the download phase, so yeah, we got a queue. When something finishes in the download phase, it puts it in the queue. This queue is used by the transform process. It listens to this queue. And whenever something arrives in the queue, it'll pull it off the queue and start working on it. So again, queue, and upload doesn't have a queue that it inserts into because it uses the queue from the transform process. Right, and then the upload, this just does a bunch of work. The upload is doing, like I said before, both bulk insertions and it's also doing individual insertions. And the way this works is it'll attempt to do a bulk insert first, and if there's already data in the database such that it can't do the bulk insert, it's going to basically fall back to the individual insertion. And this is on a per company basis, essentially. Oh yeah, so I guess I can say the way that the upload stage gets data from the transform stage, and also the transform stage gets data from the download stage, is that whenever work is done, it writes it to the queue, and in order to do operations even faster, it's going to write to the queue in time batched intervals. So let's say for the sake of argument, for example's sake, this might insert to the queue for 5 seconds, and this will wait that 5 seconds. And once the 5 seconds is up, it's going to process all the data in that queue. And the reason that's good is because, especially at the start when I'm doing the bulk download, I might have thousands of records become available all at once. And if that's the case, I can then use multiprocessing again in both the transform stage and the upload stage in order to process that data faster. So in each of these stages here, both transform and upload, I can actually break up the problem, break up the queue, whatever's in the queue, into multiple instances of this transform and upload stage so that they can be processed at the same time by all of the available threads / processor cores on your computer. Yeah, so this has multiprocessing baked in as well. And this also has multiprocessing baked in. And I guess I can, just for the sake of completing this picture, all of these are multiprocessing. And again, each one of them gets its own process. For the multiprocessing, again, this backend that I'm writing is in Python. So I'm using here multiprocessing pools, both in the transform and the upload stage to break up the queue work. And for these three individual stages, when I'm executing a new process, I'm not using a pool, I'm just individually creating a single new process for each of these individual segments. And that's all I have to say about that. Again, if you're interested in multiprocessing, I did a live stream in my last video. I'm pretty sure it was my last video. If it wasn't my last video, it was 2 videos ago. And yeah, so you can get more information on how to do multiprocessing in Python through watching that. That was specific to a multiprocessing logger, but the same kind of information applies to everything. And that's why I wanted to share it here, because you'll see that, especially if you're working with data, like this scheme essentially applies to any data ingestion process with Python, especially if it's a live feed. So cool. That's all I wanted to say there. Get that right. Okay, so that's pretty much all I wanted to say about that. I hope that's useful to any of you trying to develop data processing pipelines in Python. One of the things you might come across, especially when you're using the multiprocessing pools within each of the individual processes, is you'll run into race conditions. So you need to make sure that, well, especially in the upload phase, you'll run into race conditions. Depending on how you've structured your data in the transform phase, you may have certain duplicates that you need to iron out in the upload phase. So anyways, that's just a problem with multiprocessing in general. You have to be really aware of potential race conditions. And if you don't know what a race condition is, that's just when you get unexpected behavior because things are happening at the same time, essentially, not sequentially. So yeah, a bunch of my time was spent, well, not that long, maybe like a day or so, just making sure that the race conditions were not going to be a problem. And yeah, so that's essentially what I've been working on the past week or two, week and a half, something like that. And now I just need to write a ton of tests to make sure that all of what I just described here and implemented there is correct. So I'm pretty confident that it is. I'm just, again, also writing tests. So if I change something in the future, I know if it breaks. Depending on your development styles, a lot of people like to do test-driven development, which is where you write tests first and then make satisfy the tests with code that you write. But in this case, I was kind of learning as I was going, so I wasn't 100% sure how I wanted to write the tests. So anyways, I went ahead, wrote the code, and now I'm going to go back and write all the tests that I need. Yeah, that's it. So thank you so much for watching. I hope you enjoyed, and I'll see you in the next video.